let me tell you what is core. Actually, the basic unit of an embedded system is called core. Remember this one, the basic processing unit. Most of the people say the processor is a processing unit. Okay, that's fine, but the core is actual processing unit present in the processor. All of you remember, most of the people thinks processor is a processing unit, there is no other unit to process. But here the fact is, the core which is present in the processor is the actual processing unit. Now let me tell you the definition of core. A core is a processing unit inside a CPU. Here CPU is nothing but a simply you can say processor that executes instructions and perform calculation. Here see, at the end, whenever you want to do something with embedded system, what it has to do? It has to perform some calculations mathematically only. Whenever you want to do anything for any application, at the end, the processor will do some mathematical calculation. Then who will do that mathematical calculation? Okay, that mathematical calculations was done by the core. Remember, see, the core is a processing unit inside CPU that executes instructions. Instruction is nothing but a smallest work. You can remember, a small minute work for a CPU, and performs calculations. Here see, the modern processors may have multiple cores to handle multiple tasks simultaneously. Here remember, suppose you give a plus b and a times b to your processor or core. Let it be, this is the core. Now remember this thing, single core can do single operation in one machine cycle. It can't do multiple operations. Suppose if you give these two operations to the core to do a plus b and a into b, the core can't do two operations at the same time. So what it how can you increase the processor speed? Got my point? Suppose multiple operations comes at the same time, then your core can't do. In that time, if you want to increase the processing speed, you can install few more cores. Let it be core 1 and core 2. Now the core 1 will do a plus b and the core 2 will do a times b. Now what happened? At the end, the processing speed will get increased. Now remember one more thing, even though if you use two cores also, this two cores will be placed in single processor. Remember, if anybody comes and asks you where core presents within my embedded system is, the core will be presented in the processor. The processor can have multiple cores, and one more thing, a core can do only a single instruction, or it can execute only single instruction per one mission cycle. I'll explain you what is mission cycle in next slides, don't worry. And see here, this is the core block diagram. Actually this is the core, not central processing unit. See, this is the core block diagram. Within the core there are three important units. One is ALU, that is called arithmetic and logical unit, and second one is CU, control unit, and third one is registers. In some cores cache memory also will be included. In some other cores, these core registers itself act as a cache memory. Now I will tell you what is the use of each and every block. Okay, let me erase the things on this slide. Here see, first thing is ALU. ALU, any of you know the full form of ALU? What is the meaning of arithmetic and logical unit? Do all the arithmetic and logical operations. And remember one thing, what are the operations can be performed by the core is, you can do addition, subtraction, multiplication, division, and bitwise operations, and you can do logical operations, logical AND, logical OR, logical NOT. Here see, at the end, if you classify all these operations, only there are two operations. One is arithmetic and another one is logical. So the whatever unit which can perform both arithmetic and logical operations, that is called ALU. That is the main processing unit inside a core. I already told you, many people think processor is actually processing unit, but processor is not actual processing unit. There is a core inside the processor, that is the actual processing unit. Inside the core also there is a unit called ALU, which will do all the arithmetic and logical operations. Okay, now it will perform all arithmetic and logical operations. Now what about control unit? Okay, here control unit is nothing but, suppose if ALU want to perform a plus b operation, it is an arithmetic operation. Now first thing is it has to get the value of a, and then it has to get the value of b, and it will know what is the operation will be performed between these two variables. Okay, this everything is control unit. I mean, how can I tell you, uh, all these things will taken care by the control unit. Got my point? This ALU can simply add these two things and it will give the result. But who tells the ALU from where the A value you should bring, from where you should bring the B value? Actually, this A and B are the variables which are stored in one of the memory location that ALU will not know. ALU don't know where that where that A and B are present. Okay, that everything controls by the control unit. Got my point? And next thing is registers. Do you know anything about registers? See, actually, if whenever comes you and say what is called embedded programming, then you can simply answer like embedded programming is nothing but programming the registers of a hardware. Here remember, registers are very basic unit, but it will play a crucial role, because whenever you want to go to develop something in embedded system, then the first thing is you have to see what are the registers present in the particular hardware module, and you have to know how to program that registers. And if you program that registers, automatically that embedded system will act according to your programming on registers. Okay, it may confuse you sometimes, but don't worry, first I will explain you what is register, and then you'll get to know. uh, Let me explain you here. The register is nothing but, a register is a small and high speed storage area used to hold data, instructions or address temporarily. Here remember, a register is nothing but a small high speed storage area. Here see, storage area. So someone can ask, we have memory already. We have something, yes, RAM, DRAM and ROM. This kind of memories are there. If we already have memory, then what is the need of some other storage area? Okay, actually these memories are nothing but permanent memories. Whenever you store something in this memory, that will be permanently stored in that memory until you delete. But these registers are nothing but, these are not permanent storage units, these are temporary storage units. That means whenever you switch off your embedded system, the content present in all the registers will get erased. Okay, and one more thing, it is used to hold the data. You can hold the data whatever you want, and it is used to hold the instructions. Instruction is nothing but a program. Remember, instruction is nothing but program. A group of instructions are nothing but program. Okay, or address temporarily. And here you have to remember one more thing, it is a temporary storage unit. Okay, now see, there are mainly we use three types of registers that I will explain here: data register, control register and status register. Before that thing, let me explain you what are the sizes of register. Size of register. Size of register. Actually, mostly we see the register size is 32 bit. 32-bit registers. Why 32-bit means, actually whenever you consider, how can I tell you, any machine or any hardware, then you may see this kind of thing. This is a 8-bit machine, this is a 16-bit machine, this is a 32-bit machine, and this is a 64-bit machine. 64-bit is nothing but a high-end machine which is very fast. I hope you all hear this kind of terms. Do you, any one of you know what is the meaning of 32-bit machine? What is the meaning of 16-bit machine? Any of you know? Let me explain it here. What is the meaning of 32 bit mission? When I was explaining the first slide, then I used one term called mission cycle. Mission cycle. Any of you know what is the mission cycle? Actually, whenever you talk about the speed of embedded system or speed of any processor, you talk something like this. It is a 2 megahertz processor. It is a 20 megahertz processor. It is 100 megahertz processor, like this. Here 2 megahertz is nothing but within single second this processor can produce 2 megahertz of cycles. 2 megahertz is nothing but 2 in times 10 power 6 cycles. One cycle is nothing but for it looks like something this, one positive cycle and one negative cycle combinedly called one mission cycle. Remember, one positive cycle and one negative cycle combinedly called one mission cycle. Here see, what is the meaning of 2 megahertz mission? 2 megahertz mission means in 1 second that mission can produce 2 megahertz cycle. That is nothing but 2 times 10 power 6 cycles it can produce. And what about the 20 megahertz? In 1 second it can produce 20 megahertz number of cycles. What about 100 megahertz? In 1 second it can produce 100 megahertz of cycles. Now, what is the need of producing this many cycles? Someone can ask. The reason is, here I told you the register can store instructions, and when I was telling that thing, I told you instruction is nothing but a smallest work done by the processor. Here, what is the smallest work done by the processor is nothing but, remember, within one mission cycle, what is the work done by the processor is called smallest work. Okay, what is the smallest work done by the processor at a time is nothing but how much work our processor can do within one cycle, one mission cycle. We can call this is a mission cycle. Okay, now suppose if our processor can read or write, if our processor can read or write 8 bits in one mission cycle, then that is called 8-bit mission. Remember, here see, if suppose I have one processor or controller, 8051 controller. I think most of you know 8051 microcontroller. It is a very basic microcontroller. Actually, and you may see 8085 processor. 8085 processor. Here, whenever you see 8085 processor, somebody will tell you it is an 8-bit processor. What is the meaning of 8-bit? That means this processor can read 8-bit of data in single mission cycle. Okay, now let's take one 16-bit controller. Let it be something PIC microcontroller. I'm taking one PIC microcontroller of 16-bit. Here, what is the meaning of 16-bit mission? This PIC microcontroller can read or can write 16-bit data in single mission cycle. You know already what is the meaning of mission cycle. Mission cycle is nothing but a smallest, or you can say, if you consider the speed in megahertz, then what is the duration of one cycle, that is called mission cycle. And if you consider any STM32 microcontroller, those are 32-bit controllers. Okay, so here our STM32 controller or the processor, whatever you can say, can do 32-bit read and write operation in single mission cycle. Similarly, 64-bit. Let me explain you. Here see, if you consider that's why how to select register size means, whenever they are manufacturing the chips, first they will check what is the in one mission cycle how many bits my processor can read and write. If suppose If their processor can read and write only 8 bits, then they will design their registers as 8-bit registers. Okay, because if your processor speed is, suppose if your processor speed is different from the register size, then it is difficult to read and write. Sometimes the register size will get waste. Sometimes it's not sufficient to read the entire data from the registers. That's why how to select the register size means it is based on the machine. If it is 16-bit machine, most of your registers are in 16-bit. If it is 8-bit machine, then your registers are 8-bit. If it is 32-bit machine, then mostly your bits are, I mean the register bits are, register size are 32-bit. Okay,